Okay, hopefully I can keep this one shorter. So I'm going to start this off with a model. Okay, if you guys remember a model is when we take that circle, okay, and we say what's going in and out of it, okay, in our model. Hopefully that's the right amount of arrows, but we'll see. I'm going to make my model based on cellular respiration, and I'm specifically going to be focused on aerobic, okay, aerobic specifically. So you have to first ask yourself, what kind of creature does aerobic respiration? Because we have to say what kind of creature, where is this process happening? Where is cellular respiration happening? So I could say a human, and so if I say a human, I could say a human cell, I could say a plant cell, because if you remember correctly, plants do cellular respiration at night when they're not exposed to light, as I am right now, okay? So I'm just going to simply keep it simple. I'm just going to say a human cell. Or if you're a humongous mega brain, if you remember correctly, where in the cell does cellular respiration happen? It's in a very specific spot. It's also nicknamed the powerhouse. Happens in the mitochondria. So if you said the mitochondria, I would be mega impressed. Okay? So what are the inputs? What are the reactants? Okay? The inputs or reactants to cellular respiration. What are the outputs? Okay? And here's the one thing I need to emphasize the most. Okay? You cannot have cellular respiration without the big dog, okay? The most important substance, glucose, C6H12O6. You cannot do any respiration, cellular respiration, without glucose. You need it, okay? But the next thing that I'm about to add, you have to ask yourself, do we need that? I'm about to add oxygen. Well, it seems like I need oxygen to keep on living, but do you need it for respiration, okay? And some of you guys may be saying, yes, absolutely you do, because I'm going to die without it. But you got to remember that you can do another type of respiration without oxygen. Okay, that's anaerobic respiration. So do you truly need oxygen to do cellular respiration? No, but you 100% need glucose. Okay, so inputs, glucose, oxygen. What are the outputs? Okay, I exhale CO2. How many? 6. I exhale yet again water. How many? 6. Ooh, that 6 number keeps coming back. And last but not least, there's one thing that's also produced. It's a substance that contains our energy, and it's a 3-letter substance, and it's called, with all capital letters, ATP. I'm so glad you guys got it. Good job. Woo. Okay. This is a model, and this model mostly tracks, even though I kind of broke some of the rules, matter. Okay. How is it tracking matter? Well, you got to remember that matter is stuff. Okay, anything in all letters. So if you see a C, an H, an O, okay, any elements, that's matter. Okay, so this is tracking matter. ATP is another substance that contains matter, much like your glucose, but this is a lot less energy stored in a compound. Glucose has a ton of energy stored in it. It's almost so much that's overwhelming. So we have to break down all this energy into smaller compartments so we can power the cells. It's like putting, like, for example, if I want to charge my Xbox controller over there, it's like me attaching a car battery to it. I'm going to fry that thing. So instead of using a car battery, I want to take the energy that's essentially from that car battery. What if I could split it up into a bunch of AA batteries? So I could put like a couple AA's in the controller so I don't fry it. Okay? That's the same essence. This has way too much energy, so we break it down so it's in this smaller compounds that contains a little less energy. It contains less energy in each of the ATPs, but it's a lot safer to use, okay, per cell. So this tracks matter. And then the other thing we're going to study is energy. How do we track energy? Okay. And how we track energy is through our wonderful, wonderful LOL energy bar chart. Okay. So I'll create my LOL. Okay. I'm going to use the example of my dessert from tonight. My dessert for this evening. What was it? I had a protein shake. Vanilla protein shake. And I also mixed some yogurt in it. Okay. So I had some sugary substance for my dessert tonight. So I didn't have much energy going into tonight. So my energy human energy is called ATP, okay? But if you have no energy in ATP, the dead version of ATP is not called ATP. We actually replace the T with the D from dead. So I have ADP, okay? ADP is like the de-energized form of ATP. It means you want to have ATP, but you don't have any energy, okay? And I'm trying to get energy, and so this is like dead batteries. And that's a type of chemical energy. Remember to label your energies at the very top, okay? And so where am I going to get all my energy from? Well, I'm a creature that does cellular respiration. So I'm going to be breathing in oxygen, which doesn't give me energy. But I will be eating sugar, which does give me energy. So that's my C6H12O6. And I'm a human, and in my cell, the mitochondria, again, is going to be doing the cellular respiration. Okay? And let's say I got 5 bars of sugar energy, and if it's sugar energy, food energy, that is chemical energy. So I take this sugar, I break it down, okay, and I'm no longer going to have glucose over here. What I'm going to have is ATP, and that's my energized version of ADP. So my dead ADP turns into powered up ATP. I'm also going to make some H2O and CO2, but those won't have any energy, okay? So now the question is, how much energy is my ATP going to get, okay? Well, you should always remember, when you're crossing over from one L, or one energy bar chart, to another, there's this human cell, mitochondria. And the question is, do we always keep our energy when we move from one part of the chart to the end of the chart? And all of you guys should remember that we always lose energy. But the question is, this bar of energy, how am I losing it? The most classic way for at least living creatures like humans, or I shouldn't say living creatures like humans, but mammals like humans, warm-blooded animals, we release it usually as heat. So if I start with 5 bars, lost 1 bar to heat, well, 5 minus 1, that means for my ATP, I'm probably going to have 4 bars left, and that will be of chemical energy, and I will have no chemical energy within water or CO2. Okay, it's good to practice these energy bar charts. They're on the review for a reason. Okay, never forget, you always lose energy no matter what. Okay, you always lose energy. Okay, I hope that makes sense so far. So I'm going to start erasing this. I might be using the full 15 minutes. I'm so sorry. I cry. Okay, let's set that back down. Looking to see if I missed anything so far. No, of course I didn't, because I'm awesome like that. So, next what we're going to cover, energy pyramid. Okay, energy pyramid. We all love energy pyramids, or pyramids. And when you guys become a grown adults, you will love pyramid schemes. Mary Kay, you know. So, energy pyramid, shaped like this, what it shows is energy movement throughout the levels. Okay, so these are called trophic levels. And as you go up, you notice that the pyramid becomes more narrow. Okay, it loses width, essentially. But first, let's try to figure out which creatures go in each of these. Okay, I'm going to give you guys 1 second. I want to see if you can figure this out. Which kind of creature goes in each of these levels? Stop. Okay, hey, you're back. So, at the very bottom is always going to be your autotrophs. Your autotrophs make their own energy, and the reason they're called autotrophs is auto means self, troph means food, make their own food. That's plants. Plants make their own food. They make their own sugar. They make their own glucose. Okay, so these are essentially your plants. Then we have above them, the creatures that eat plants are called herbivores. The creatures that eat other animals are called carnivores. And the creatures at the very, very top of all the carnivores are called the apex predators. Okay, they're the apex. Nothing hunts them. Okay? So, if this is an energy pyramid, well, how is the energy being transferred? Well, it's going from one level to the next. but it looks like not as much energy is making its way to the top as there is on the bottom. So the question is, how much energy is actually being transferred? Okay, special number, double digit. Let's see if you got it. Oh, you got it. I know you said 10, right? Yep, 10. Great job. So only 10% gets passed on from each level. Okay. So essentially, if the autotroph starts with 200,000 calories, well, that means only out of 200,000, only 10% of that's going to make it to the next level. So that's 20,000. And of this 20,000, the carnivores are only going to get 2,000 of these calories. And that means the apex predator is only going to get 200 of the calories. Okay? So when in doubt, every time energy passes through another living creature, you essentially take out a zero. So I took out the zero here, and then here, and then here. Okay? You remove a zero every time you go up the pyramid. Okay? So energy is transferred as you go up, and the apex predator gets the least amount of energy. The autotroph not only has the most energy, but based on the size of the level, it also has the most organisms, which means there's a lot of plants at the bottom of the pyramid, which means the top of the pyramid has few organisms. There's only a couple creatures at the very top, and if the creatures at the bottom, like the plants, have all the energy, and the apex predator only gets a little bit of energy out of the big scheme of the thing, the apex is going to need the most energy. And so they're going to keep hunting for said energy, hunting other creatures, so they can keep trying to put in as much food as possible because they only get so many calories out of the big scheme. Okay? So energy pyramid passing on through and through. Okay? I would do an example of a food web or a food chain, but I think that's a complicated example for this review. And the review on the homework provides better examples for you to go over, so I don't know if it's really worth my time as of now. The last thing is, how do we get our energy? How do we humans get energy? Energy. Where does all the energy come from? How does a human get their energy? Okay? Well, you have to remember, all the energy on this planet, mostly, okay, comes from the sun. Okay, the sun powers everything. So the sun is the most important thing. If the sun goes away, there's almost going to be no life. Okay? Unless maybe by like hydro vents at the bottom of the ocean. Okay? So we have the sun. But we need something that can harness the power of the sun and turn it into energy and matter so other creatures can eat it. And the kind of creature that does that is plants. Okay? Plants take energy from the sun and they use their organelle, the specific special organelle, which I would like you to remember the name of, called the chloroplast. Okay? And the chloroplast will make glucose, sugar, and that's the stuff we want. So what's going to happen with the sugar? Well, the glucose is going to go into a human. And within the human, in our cells, we're going to break it down, okay? And the specific part of our cell that breaks it down is called the mitochondria. And the mitochondria will then make ATP for us so we can get our energy, okay? That's the big scheme of everything. We need not only ourselves to keep hunting and feeding off of sugar, but we need plants. We need to feed off them because they're the guys that make the glucose because they have chloroplasts. And they get everything from the sun. The sun is the most important thing. It's almost our caretaker. It keeps us warm, but it also gives us almost everything we need. Okay? It provides weather, it provides food, and it provides warmth. Okay? So the sun is the most important thing to every ecosystem, every living creature. Okay? Plants are number 2 on that list. So I hope this video helps. Videos too, plural. And if I'm a super kind, nice, awesome teacher, maybe I'll make an answer key for the review tomorrow. And if you stay around to the end of this video now, you know that maybe around like noon, 1 o'clock, Mr. BB might be posting an answer key to the review so you can check all your answers. What? That's crazy. Thank you for watching this entire video. I hope you do well on your test, but it will be starting Wednesday, which I believe is tomorrow. I'll get these uploaded. Thanks for watching. Bye-bye. Bro fist.